So in this question here, we're going to calculate some binomial distribution inequalities. So the main goal here is going to be to calculate the probability that x is in between 3 and 6 inclusive. And on each one of these questions, we're also going to calculate the mean and the variance. The second one, we've got the probability that x is between 10 and 14 inclusive. And on the third one, the probability x is between 180 and 301 not inclusive, and it's not the equal sign on the inequalities. And as it's the binomial distribution, each one has been given its own distribution parameters. So the binomial distribution is binomial of n, p. N is the number of trials and p is the probability. So with that, the probability is always between 0 and 1. And if it's 1, it's a bit boring, it's a bit trivial. So you don't really need to do calculations for 1 because it's guaranteed to happen. So the probability of something happening will always be 1. And then in this case here, 0, that means it's never going to happen. So the probability of it's always going to be 0. So 0 and 1, it's a bit trivial. So probability is always between 0 and 1. And the number of trials, n, is always greater than 0 because if there's no trials, there's nothing to do any testing on. Now to calculate the mean and the standard deviation, I've got the formulas written here. The mean of the binomial distribution is quite a nice easy formula. It's just n times p. So whatever's in here, you just multiply it together. And then standard deviation squared, which is the variance, is np times 1 minus p. Sometimes people will call this 1 minus pq, in which case it's npq. And as np is the same as mu, you can also write the variance as mu times 1 minus p. Okay, so we've got 3 examples here which we're going to run through. So the first case, x is distributed binomially 8, 0.4. So 8 is the number of trials and the probability of a success is 0.4. So just to start off with the mean, we do n times p. So 8 times 0.4 should give us 3.2. So that's going to be the mean of our binomial distribution. So that's probably the most likely kind of position. The variance is going to be 8 times 0.4 and then 1 minus p, which would be 0.6. So we times this by 0.6, we get 1.92. Okay, now let's have a look at this inequality. Now here, the thing to use on your calculator would be the binomial CD function. And it will ask you for your parameters. It will ask you for your n, your p, and your x, depending on this calculation here. So that will calculate all the values from that and down to 0. And it'll be the sum of all those calculations. So here for this inequality, we're going to need 2 steps to try and work it out unless you've got this function in your calculator. So if you haven't, the way to do that is to start off with the higher value. So the probability that x is less than or equal to 6. So that gives us all the values summed up all the way to 0. And then subtract that, carefully picking our boundary for the lower bound. 3 is included, so we want to deduct all the ones up to and including 1 less than that. So as it's discrete data, the next one's going to be 2. So x is less than and equal to 2. So we then go along, put that in our binomial CD function on a calculator, and x will be 6 and then 2, and then subtract the 2 results. So probability x is less than or equal to 6 is 0.9915. And x is less than or equal to 2. Put that in a calculator, we get 0.3154. And then you can see it's the difference of those. So you can also do that in your calculator and you get 0.6761. So that's our probability of that happening. So if I put that to there, that's our result. Okay, so now let's try this result. So slightly different distribution, slightly different probability, and the inequality calculations are also different. So first of all, let's go with the mean and the variance. So mu is 17 times 0.39. Well, 17 times 40 is 680, minus 17 is 663, so it would be 6.63. And then for the variance, we just get the 6.63 and times it by the 1 minus this, which is 0.61. And if you do that, you get out of your calculator 4.0443. So that's our variance. Now let's deal with our inequality here. So again, we take the upper bound and it's inclusive, put it into our binomial CD function on our calculator. So then we've got the probability x is less than or equal to 14 minus x is less than or equal to. Now, as 10 is included in the inequality, we take the next one down, which would be 9. That would then lead us to our answer. So we could do that binomial CD calculation and subtract that one from our result for this one. So if we do that, this one is going to give us 1.00 as good as. I know it's going to be slightly less than that, but maybe to about 20 decimal places. So it's good enough to be 1. Then we subtract from probability x is less than or equal to 9, which is 0.9216. So do that in your calculator, you get 784. So 0.0784. That's our probability for this one. Okay, now on to this last distribution, which has got a much larger amount of trials, and the probability now is 0.6. So let's do with our mean and our variance to start with, or standard deviation squared, whichever way you want to look at it. We got 501 times 0.6, so put that in your calculator, you get 300.6. And then for the variance, times this by 0.4, so if you do that, you get 120.24. So that's the easier calculations to do to start with. Now we've got to deal with this inequality. Now, here we haven't got the equal signs, we've just got less than both times. So what it would say is here that 301 is not included in our calculation here because it's got to be less than that. So as it's discrete data again, the next one in the line is 300. So we want the probability x is less than or equal to 300. Okay, now we need to find where our lower boundary is. So we've got 180 here, and it's going to be less than 180 to find our value that's not actually included. So the one that's included between 300 and somewhere here, that's going to be 180. Because if it's going to be larger than 180, then what we have to do is subtract the values up to and including 180, because 180 is not invited. So less than or equal to 180. Okay, so now plug those in our calculator. So this one will give us 0.4951, which is, almost the centre of our data. As you can see here, the mean is 300.6. So it seems logical that for 300, you're almost a half, as that's the mean. So the mean of the binomial should be halfway. So that should be about halfway too. So then half of the data is this side. So now 180. So put that in our calculator, we get almost 0. So again, similar situation, a bit like with this one. It's not actually 0, but it's so close to 0 that we just consider it as 0. And then subtract those, pretty straightforward, 0.4951. And that's our probability for that one. And that's our binomial distribution inequalities taken care of. Okay.